This is lesson 8.7, part 3. So we're looking at special right triangles in this whole section. Our first day, we looked at 45, 45, 90 triangles. On day 2, we looked at our 30, 60, 90s. And now we are sliding down to the bottom, and we are going to be working on the area of regular polygons. So we'll be using the same skills. We'll have to translate those 44, 45, 45, 90 skills and our 30, 60, 90 skills to this section. But not every single problem is going to force you to do that. So let's take a look. We'll come back to this vocabulary word in a second. So again, this is just for regular polygons. Just a reminder what that means. All sides and angles are equal. So this is not for any polygon, just for regular polygons. But it doesn't matter how many sides it has. If it's a regular polygon, this formula will work. Okay, so the area of a regular polygon equals 1/2 times little a times little p. So little p is the perimeter. So you add up all the sides. Little a is this new word called the apothem. So we use a capital A for area, and we're going to use a little a for apothem. And that's the segment drawn from the center of a polygon to the midpoint of a side. And so right here on this first problem here, we have a pentagon. And this would be the apothem. It goes from the center of the polygon to the midpoint of a side. Now notice that's different than what's called the radius of a polygon. The radius of a polygon, let's go ahead and define it, even though we're not going to use it in this section. We got to know the difference because sometimes they will actually give you the radius and you can't use it for the apothem. So you got to be careful. The radius is, we're going to kind of mirror this definition. It's the segment drawn from the center of a polygon. I'm not going to write that part out, to a vertex. Okay, so the apothem goes from the center to a midpoint. The radius goes from the center to a vertex. That would look like this. Okay, creating those little triangles. So we are actually going to use those sometimes, but it's not part of our formula. When we plug in for little a, it cannot be this length. If you look at this little right triangle that was formed, we know the hypotenuse is going to be longer than this side. So clearly if this is 2, this can't be 2. It's a different number, so we cannot grab a radius and plug it in for little a. So that's where we need to be careful. So let's start off with this, just the real basics. 1/2, little a, little p. We've got pretty much all the information we need. The apothem was given to us, it's 2. And then the perimeter, you would have to add up all your sides. Be careful. Common mistake is people will just grab this number right here. And so I've got 5 sides. Each one is 2. 5 times 2 is 10. So perimeter is 10. 10 times 2 is 20. And you take half. And this is 10. Now, just so you know where this came from, if you look, you've got these little triangles that are formed when you draw the radius to 2 of these vertices. And let's just say you wanted to find the area of one of these triangles. They're all going to be equal. There's going to be 5 of them. And so if you found the area of one, you could just times it by 5, and that should get us to the same thing. So let's take a look at what happens here. So this is going to be just the triangle. Area equals, a triangle is 1/2 base times height. The height is 2, the base is 2. 2 times 2 is 4. Take half. It's 2. So the area of one triangle is 2, and you would times it by 5 to get the area of the whole shape, which gets us to 10. So that extra multiplying by 5, because we're using this number and this number, we did the multiplying by 5 over here when we calculated the perimeter. So we're still doing all the same multiplication sequences, which is why they come out to the same thing after you times this by 5. But we've just packaged it inside of this by calling this the perimeter. So instead of just dealing with one side, we're dealing with this height, which we call the apothem, and we're dealing with this whole side, which is the base in this smaller triangle formula. But then because we're going to ask for the perimeter, we're going to go ahead and times it by 5 and that number gets plugged in. But we've actually done the 1/2 times the 2 times the 2 times the 5 here, and we've done it here. It's just packaged a lot nicer now in this formula right here. So that's how that works. Okay, so they're not always going to give you the apothem. If you take a look, this next one, I don't love the numbers now that I've run them. It's going to get a little weird with the decimals on this question, but we're going to look at a couple examples. And so we'll run through this one real quick. But this length right here is not the apothem. It's going from a vertex to the center. That's a radius. This would be the apothem. It's going from the center to the side. So we need to find that. That is little a right there. All right, now the apothem is always going to hit the side at 90 degrees and form these nice little right triangles. So we can do a squared plus b squared equals c squared. So I'm going to redraw this real quick. 7.2 is out here. It's the hypotenuse. We're looking for little a. And this bottom piece, be careful, is not 4.45. You're going to go ahead and divide that by 2. And so if I divide 4.45 by 2, it's 2.225. I've already run these numbers, so you don't need to watch me punch them back in the calculator. Just trust me on these. But now I can do a squared, b squared, c squared. And I'm doing all this so that I can use this formula. I already have a side length. I could figure out perimeter, but I don't have the apothem. I can't use 7.2. That's the radius. I need the apothem. So we're going to plug this all in. I'm going to plug 2.225, that gets squared, in for b, and c is 7.2 because that's the hypotenuse. Those are going to get squared. Again, I've already run these numbers, so I'm just going to go ahead and write them down for you here. These numbers get long, and I'm not going to round it. I want the exact answer. So when I square 2.225, it's 4.950625. And I'm not going to give you a problem where you have to do this. I wish I would have looked ahead when I made the notes, but we'll deal with the decimals. It's not like you'll never have to do this in your life. Sometimes you got to deal with nasty decimals. 7.2 squared is 51.84. Okay, you would go ahead and you would subtract this, of course. So subtract. That's going to leave you a squared. This is going to go away. And when I subtract this long number, I'm not going to rewrite it, but when I subtract it away from this, I get 46.889375. And of course, that's not the actual length. I would square root. All right, and then the square root here, 6.8475869. Okay, so now I have enough information to go ahead and run this. Area equals 1/2, little a, little p. So 1/2. I'm not going to write this all out, but for little a, when I punch it in my calculator, I'm using this big long number. And then the perimeter, we got to count up our sides here. Be careful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we have a decagon. We've got 10 sides here. So we're going to do 4.45 times 10, which is 44.5. So I've got that in my calculator here. I'm going to times it by the apothem, so I'm going to write out that whole thing. 6.847581169. And then, of course, I've got to take half. And then when we get to our final answer, it's okay to round. If we had rounded these numbers super early and then squared them and square rooted them and kept rounding, we would be pretty far off from this answer. This answer is really close to the exact answer, so now we're just going to go ahead and round it. And so we'll say that this is approximately, and so I'll use a little squiggle, 152.4. So that got a little goofy with all of the decimals, and so we're going to do some more, and you'll see it's not always going to be that crazy with the decimals. But I wanted you to see a problem where you have to use Pythagorean theorem in order to find a missing side, and that is the apothem. In this case, it's going to be different every single time. All right, when we now look at this last example, They're telling you it's a regular hexagon with a side length of 10. You notice they don't give you anything else. And so this is where we have to start using our special right triangles. So here's what happens. What we want to do is we want to go ahead and put the center down, and let's draw a radius and a radius. And then, so I called it a radius because I went to the vertex. I'm basically cutting this up like a pizza into slices, right? And there's going to be 6 slices total. And then down the middle of that, I'm going to draw the apothem, which hits at 90 degrees, cuts one of those sides in half. So I've got sides of 5 and 5. Now, I'm going to go ahead and draw another one over here. You could draw all of them if you wanted to. Sometimes the more lines you draw, though, it starts to get confusing looking. I've got different colors, so it helps if you don't have different colors. Then it just starts to look like a whole bunch of lines, so you may not want to do all of them. But I've got 6 pieces. Now, let's talk about angle degrees. They didn't give us any degrees to form a 30, 60, 90, or a 45, 45, 90, or anything like that. But we know that all of these angles together is going to be 360. And so if I cut that into 6 slices, forget the apothem right now. If I just cut this into 6 slices, 360 divided by 6, I know that each one of these angles is 60 degrees. 60, 60, 60, all the way around. And so this whole top of the triangle is 60. And when you draw the apothem, it does in fact bisect that and cut it in half. So I'm going to get a 30 and a 30. These little triangles, when we cut this all up, they're going to be nice little equilateral triangles. All of these angles are going to be 60. Now we already know once we've got 30 and 30 right here, and this is 90, we know that these are 60. Okay, so it's a 60, 60. This whole angle would be 60. But now just looking inside these little triangles, I'm going to go ahead and separate that little triangle. Here's my 90. So this piece is 5. Again, I'm not looking at the whole bigger triangle with the side of 10, just this little 30, 60, 90. This is 30. This is 60. We don't really care about how long the radius is. That doesn't help us. Our main goal here is to plug into the equation 1/2 little a times little p. So we can already figure out what p is, right? 10 times 6, it's going to be 60. But what we don't have is little a. So right now, we don't have little a. Little p, the perimeter, that's just going to be 60, 10, 10, 10, 6 times all the way around. But now using this little 30, 60, 90 triangle, I can find this length, which is the apothem, that's little a. Across from 30 is x. Across from 60 is x radical 3. So if x is 5, I can just plug that right in, and it's 5 radical 3. So that length right there is 5 radical 3. That's the apothem, 5 radical 3. And now I have enough information, I can go ahead and find the area. And so when we have these radicals in here, if you had more than one radical, you can multiply them together. But you're not going to multiply the radical with the whole numbers. The whole numbers just get multiplied with the other whole numbers. So you're going to do 60 times 5 and take half. The radical 3 will just tag along, and that comes out to 150 radical 3. All right, so we are going to try some other problems here together. If you're in class, we'll be running through this together. But if you weren't able to be in class, you will be able to run through these with the video here. Let's go ahead and put that back in focus for you. All right, so each one of these is a little bit different, and we'll work our way through. The first one is very simple because all the information we need is there. So area equals 1/2 little a little p. Little a is 9. Little p, count 1, 2, 3, 4, 5, 6, 7. We got 7 sides. So let's go ahead and multiply. 8.7 times 7. You might want to write this over here just so we know what we did. That comes out to 60.9. That's the perimeter. So we're going to plug in 60.9 for perimeter. We're going to run that through, and our area comes out to 274.05. So if they give you the apothem and they give you a side length, it's pretty much plug and chug, and you're good to go. Okay, number 2, they've given us the apothem, so area equals 1/2, little a, little p, 1/2, little a is 8. Notice it's not the radius, it's not going to a corner, it's going to a side. Okay, if it hits at 90 degrees, we know that that's the apothem and it's going to cut this side. It's going to bisect it because it's the midpoint. But now we don't have the perimeter because we don't know the side lengths. So what we're going to do is we're going to go ahead and draw these triangles. I'm going to just draw 2 of them. The one we're going to use down here and then this one. So I would end up with 6. So just like the example in your notes, you would do 360 divided by 6 to figure out what these angles are in here. All the way around is 360. We're cutting it into 6 pieces. If you want to draw all 6, you can. But we know that's going to be 60 degrees. So this is 60, which means in here, the 60 is getting cut into 30 and 30. So I think it helps to redraw these a little bigger so you can deal with it. So I'm enlarging this one right here. It's 30 degrees. Up top, the length of this side is 8. That means this is 60. And what I need is this length out here. If I can get that, I can get the whole side length because this is going to be the midpoint, so it's bisected. And then I can find the perimeter, which is the only thing I am missing. So the 8's across from the 60. I need what's across from the 30, which is my x. Well, across from 60 is my x radical 3. So I got to do some work here to find out what x is, and then I'm going to use it to find the perimeter. So 8 equals x radical 3. Divide by radical 3. This is what x is, but we don't leave it with the radical 3 down there, so we're going to multiply top and bottom by radical 3. So on the bottom now, I get 3. And on the top, I have 8 radical 3. That doesn't simplify. Now, it's nice when this number down here can divide with that number, but in this case it doesn't. 3 doesn't go into 8 evenly. So we're going to leave it just like this. So that little piece right there is 8 radical 3 over 3. So if I want the whole side, I'm going to times this whole thing by 2. It's like 2 over 1. It's just going to get multiplied up here. That's going to be 16 radical 3 over 3. The only thing that really gets affected is the 8. So I'm doubling it. That's an entire side length. Okay, and then for the perimeter, since there's 6 of those sides, I'm going to times this by 6. Now that looks nasty, but we don't really need to deal with this square root. It's kind of just going to hang in there and follow along. So if you wanted to use your fraction button, you could. We're not going to plug the radical 3 in there because that's going to give us a nasty number. So you would just do the 16 over 3, and you would times by 6. And look at that. You get 32. So this becomes 32, but don't forget about the radical 3. It's still tagging along. If you multiplied by the square root of 3, you get this nasty decimal. We don't want to deal with that. Okay, so we're going to leave this 32 radical 3. The other way you could have gone about this was 16 times 6 and then divide by 3. That'll also get you to the 32. Okay, so we've just found out the perimeter is 32 radical 3. Again, how did we get there? We used the 30, 60, 90 to figure out that this little piece is 8 radical 3 over 3. We doubled it times 2 to 16 radical 3 over 3. That's the length of the whole side. Times 6 sides to get the whole perimeter. So this is the perimeter. Plug it in. All right, and then you're going to do 0.5 times 8 times 32. Notice I didn't times by the square root of 3 because that's going to give me a nasty decimal. I'm just going to let that square root of 3 come all the way through. And since we're giving an exact answer, we leave it just like that. Okay, let's slide down. If you are following along with this outside of class and you think you're kind of starting to get it for either one of these, you may want to just pause the video and try it yourself first and then replay the video and see how you did. But that's up to you how you want to go about this. All right, number 3, we know this is a regular triangle, so all the sides are the same. So if that side's 12, that side's 12, that side's 12. So area equals 1/2, little a, little p, 1/2. We don't have any information about little a right now. We're going to have to go get that. But the perimeter is 12 and 12 and 12. 12 times 3 is 36. You may want to write that just so you know where that number came from. Okay, so we got to do a little bit of work to go find the apothem, and we don't have anything going on yet, so we kind of have to build this ourselves. So go ahead and put the center of the triangle there. Let's go ahead and draw a radius to each one of these vertex. And then remember, the apothem drops down in the middle of that little triangle, hits the side. That's little a. That's what we're looking for. And we're going to use our knowledge here to figure out what angles we're dealing with. So we're cutting 360 into 3 pieces. That would be 120 degrees. So each one of these is 120 degrees. So this whole one's 120, and it's getting split then by the apothem into 60 and 60. And since this is 90, I know the apothem hits the side at 90. This is a 30, 60, 90. We know it cuts this whole side in half. So if this whole side is 12, I've got 6 and 6. So if I go ahead and redraw that triangle, let's isolate that little triangle, the 60, the 90, the 30. The bottom here is 6, and we are looking for little a over here. So we're going to use our 30, 60, 90. That's our x. This right here is our x radical 3. So I'm going to go ahead and write 6 equals x radical 3. I'm going to solve it. So divide. Can't leave it like this. So we're going to multiply by radical 3 over radical 3. So I get whole number 3 on the bottom, 6 radical 3 on the top. I can divide this. So this divides nicely into 2 radical 3. So the little a is 2 radical 3. 2 radical 3. 2 radical 3. The reason that dropped in there so nicely is because it's across from the 30. That's your x. So we found out what x was by solving through this. Now you just plug it right in. So again, when you multiply these numbers, you leave the radical 3 alone. Half of 2 is 1. 1 times 36 is just 36. And the square root of 3 tags along. So if it said round to the nearest tenth, you would actually plug this in your calculator, take the square root of 3, get that nasty decimal, times it by 36, you get another nasty decimal, and then you would just round it off to whatever it asks you to do. But we're leaving everything in exact form. Okay, last one. We're now looking at a square. It's assumed that these are all regular. It says that in the directions. It's a regular polygon. So if we have a 4-sided shape, all of these angles are the same and the sides are the same. We know it's a square. So what I'm going to do here, let's set this up first. Little a, little p. Be careful, we don't have little a. That's not little a. Little a goes from the center to the side, 90 degrees. Okay, this is a radius and it's 12. That is not the number we plug in. So we're going to deal with this little triangle. So what I'm going to do is I'm going to go ahead and draw another one this way, and this way. And we're just going to look at these 4 triangles. It's 360 all the way around. We're cutting it into 4 pieces. 360 divided by 4 is 90. So this guy's 90 and this guy's 90. And then this whole one's 90, but when we drop the apothem down, it's going to cut it into 45 and 45. And since these are 90 degrees, it's going to be a 45, 45, 90 triangle. And we want little a in here. All right, so if I separate one of those little 45, 45, 90s, we'll use this top one up here. This length right here that was given to us out here, that's 12. And we are looking for this piece right here. So on a 45, 45, 90, the hypotenuse is x radical 2. So I'm going to solve this. These are both x. So if I find out what x is, I've got little a. I'm also going to need this piece out here because that's going to help me get the perimeter. So I need both of these. They're both going to be the same because in a 45, 45, 90, it's x, x, x radical 2. We have an isosceles triangle. Let's go ahead and run this through and figure out what we got. So 12 equals x radical 2. It's in the x radical 2 spot. So we're going to divide by radical 2. And we don't leave it that way, so we are going to times by radical 2 on the top and the bottom. We're going to get whole number 2, 12 radical 2, divide the 12 and the 2, and that's 6 radical 2. So each one of these pieces is going to be 6 radical 2. So I've got 6 radical 2 for the apothem. And for the perimeter, we're going to have to figure that out. This other side is also 6 radical 2. Both of these are x. It's x, x, x radical 2. So both of these, 6 radical 2 here, 6 radical 2 here, which means this guy's 6 radical 2. That's just this half of that side. So if I double that, the whole entire side is 12 radical 2. You times it by 2. So every side of this is 12 radical 2, 12 radical 2. All the way around, this one's just been cut in half, 6 radical 2, 6 radical 2. But for the perimeter, I would take 12 radical 2 and just times it by 4, which is 48 radical 2. That is our perimeter. So 48 radical 2 is going to pop right here. Now again, we normally just leave the radicals alone and deal with the whole numbers when we get to this point, but we do have two radicals. Multiplication can be done in any order. So I can go ahead and multiply radical 2 times radical 2 right off the bat. We know that that just becomes positive 2. And so I can do 1/2 times 6 times 48 times 2. Okay, instead of dealing with those radicals right there. We run that all the way through. Area equals 280